A very good day to everyone. We are from Group 13. My name is Navishya Gengarajan and my metric number is A20A1582. Today, my group members and I would like to present on the dataset of vehicle fuel consumption per 100 kilometers with 392 observations. Now we will look into our data description. We have two different types of variables, which are categorical variable and numerical variable. In our categorical variable, we have the brand of cars, which are Mercedes, Audi, BMW, Ford, Honda, Opel, Citroen, and Datsun. Whereas for our numerical variable, we have 5 variables, which are liter per 100, horsepower, KPL, cylinder, and weight. Based on our dataset, the number of classes that we have found is 9. Therefore, our class width for liter per 100 is 1.00, KPL is 4.18, horsepower is 0.20, cylinder is 0.56, and weight is 0.39. These are the tables for liter per 100 and KPL. Based on each table, we have found the class, frequency, midpoint, relative frequency, cumulative frequency, FX, upper boundary, and lower boundary. This shows the table for cylinder and horsepower. Lastly, this is the table for weight.
Hi, my name is YASMIN binti ISMAIL. My metric number is A20A1625. Next, I want to present about sampling data and record all categorical data.
Firstly, for sampling data, we use the apps which is IBM SPSS statistics. In this sampling data, we randomize 150 observations from the data file. Then we must choose the last 2 digits of ID numbers, which is 82, 28, 14, 25, and 23. The lowest 2 digit number of our group is 14. After that, we select the cases function in SPSS statistics. Firstly, we select the cases function of the data. Then select cases, choose random sample of cases, and select exactly. For our group exactly, 150 cases from the first 64 cases. It is because 150 plus 14 then get 164 cases. Then we select the delete unselected cases. Next step, we save the SPSS spreadsheet. We go to the file and choose the file save as and select Excel 2007 through 2010 for us to generate Excel sheet. Here we can see the Excel file after we save the sampling data from IBM SPSS statistics to the Excel sheet. Next is record categorical data. After doing the sampling data, we must record all categorical data in SPSS statistics. Firstly, we select the cases function of transformation and select record into different variables. Secondly, we choose a variable of brand and select and change the name to brand category. After that, we select the all and news values. From the data given, only 7 brands that we have after we do the sampling data. We pick the all category and change to the new category. This is the all category and this is the new category. This is the data after we change the all category to the new category. We can see at here the data of brand is different from the data category because we record the data back. Next, we go to the variable view, which is at here, and select the column of values. Then we put the number in the column value, which is 1 until 7. After that, we put the number of brand in the level column, which is at here. Last but not least, this is the result after we record all the categorical data from the column of brand to the column of brand category.
Assalamualaikum and a very good day. My name is RUZANNA and my metric number is A20A23.4. Moving on to the next part, which is the numerical descriptive measures, which displays the measure tendency for each sectors that has been calculated, which shows the mean, median, and mode. So the mean for liter per 100 is 4.78 with a median of 4.01 and a mode of 4.36. Meanwhile, travel distance in kilometer per liter shows a mean of 23.51, 22.03 for the median, and a mode of 25.05, and the respective mean, median, and mode for cylinder, horsepower, and weight that has been calculated. For the measure variation part, the table shows the range, the sample variance, and the standard deviation calculated for each sector, which is fuel consumption per 100 kilometers shows a range of 8.99 with a sample variance of 3024.82 and a standard deviation of 55. Meanwhile, travel distance in kilometer per liter shows a range of 37.61 with a sample variance of 76758.52 and the standard deviation that shows 277.05 and the respective range, sample variance, standard deviation for the rest of the sectors, which is total engine cylinder, total horsepower, and weight for each vehicle. In addition, for the measure position section, the table shows the first quartile, the third quartile, and the interquartile K range calculated based on the 5 sectors, where fuel consumption per 100 kilometers shows a first quartile of 2.94 and a third quartile of 5.49 and interquartile range of 2.55. Meanwhile, travel distance in kilometer per liter shows a first quartile of 16.8, 28.91 of the third quartile, and 12.11 for the interquartile range, and the respective first quartile, third quartile, and interquartile range for the rest of the sectors, which is the cylinder, horsepower, and weight.
Continue, this is the class that we use to draw a histogram and frequency polygon. In this table figure, the graph represents the midpoint x-axis and the frequency y-axis. The per 100 graph, it shows the highest and the lowest class on the axis. The frequency of the data is represented by the varying height of the bar. The highest frequency in this graph is 102 and the midpoint is 3.65 and the lowest is 1 with a midpoint 10.65. All the bars are the same width, since all the intervals are equal and continuous. The frequency polygon, the highest is 102 and the midpoint is 3.65 while the lowest is 1 with a midpoint 10.65. This is the class that we use to draw a histogram and frequency polygon for KPL. The second histogram is for KPL. The frequency of data is represented by the varying heights of the bar. The highest frequency in this graph is 83 and the midpoint is 90.45. And the lowest is 5 with midpoint is 40.35. All the bars are the same width since all the intervals are equal and continuous. Same for the KPL frequency polygon graph. The highest is 83 and the midpoint is 90.45 while the lowest is 5 with the midpoint 40.35. Next, this is the class that we use to draw a histogram and frequency polygon for cylinder. The highest frequency in this graph is 199 and the midpoint is 3.84 and the lowest is 0 with 4 different midpoints, which were 4.4, 5.52, 6.64 and 7.2. All the bars are the same width since all the intervals are equal and continuous. Same for the cylinder frequency polygon. The highest is 189 and the midpoint is 3.84 while the lowest is 0 with 4 different midpoints, which were 4.4, 5.52, 6.64 and 7.2. Next, this is the class that we use to draw a histogram and frequency polygon for horsepower. Next graph is for horsepower. The highest frequency in this graph is 150 and the midpoint is 0.69 and the lowest is 1 with the midpoint is 2.36. All the bars are the same width since all the intervals are equal and continuous. Same for the horsepower frequency polygon graph. The highest is 150. The midpoint is 0.96 while the lowest is 1 with the midpoint 2.36. And the last is weight. We use this class to draw a histogram and frequency polygon for weight. Weight. The highest frequency is 86 and the midpoint is 2.2 and the lowest is 1 with the midpoint 5.32. All the bars are the same width since the intervals are equal and continuous. Same for the frequency polygon. The highest is 86 and the midpoint is 2.2 while the lowest is 1 with the midpoint 5.32.
Okay, I will explain. My next part is numerical descriptive measure. They have 3 numerical descriptive measure, which are measure of central tendency, measure of variation, and also measure of position. The table shows the statistic of measure of central tendency. SPSS show that the mean of liter 100 KPI cylinder horsepower and also weight is 0.3089, 60.592, 7.19, 1.3621, and 3.84936 respectively. One using manually get 4.78, 23.51, 1.30, 1.05 and 2.96 respectively. So the median of each variable is about 6.2500, 60.00, 8.0, 1.40 and 3.802250. By using manually it is 4.01, 22.3, 4.15, 0.46 and 2.31 respectively. Next the mode is 7.69, 30.0, 1.50 and 3.510. By manually is get 4.36, 25.05, 3.34, 0.39 and 2.54 respectively. We move to measure of variation. Okay, the next part is measure of variation. The table shows the statistic of measure of variation. The PSS shows that the range number of liter per 100 KPL cylinder horsepower and weight is 7.85, 21.7, 4, 1.963 and 2.119. When we manually we get 8.99, 37.61, 5.03, 1.99 and also 3.899 respectively. To move the variance number of each variable is we get 1.753, 30.969, 1.258, 1.45 and also 277. While using manually is about 3024.82767558.52, 8138.7, 149.41 and 165.29 respectively. The standard deviation number is 1 is 32404, 3.7, 373, 1.121, 38095 and 526.584. When using manual is about 0.5, 270.05, 42.88, 12.22 and 40.69 respectively.
Okay, this is the last one, numerical descriptive measure. The table shows the statistic or measure of position.
Synthesis testing, t-test. According to the SPSS result, it showed that the analysis of t-test for the dataset of vehicles brands by liter per 100 kpl, cylinder, horsepower and weight. The value of significant 2 minus type is 0.0 is less than 0.05. It means that there is a significant difference between the vehicles brand by the variables. ANOVA. According to the SPSS result, the p-value from the ANOVA table is 0.00 and the result is statistically significant because p-value is bigger than A. We are using the dependent variable which is a data set of vehicles, brands by liter per 100, kpl, cylinders, horsepower and weight to analyze the p-value outcome when we carry out the ANOVA analysis.
Next, we move on to correlation analysis. This is a table that shows based on the Pearson correlation analysis using the SPSS software. From here, we can measure the correlation between the liter per 100, kpl, cylinder, horsepower and weight. The R values between these 5 variables is 1.00. In our correlation analysis, we have even found the scatterplot matrix. This is the scatterplot matrix between liter per 100 and kpl, liter per 100 and cylinder, and to a lesser extent between liter per 100 and horsepower. It shows that there is no clear association between liter per 100 and weight. Therefore, from the independent variables, there is a high level of association between liter per 100 and cylinder.
Next, I want to present about confidence interval. The 95% confidence interval is mean upper 0.05 for mean. The later 100 for the upper boundary is 4.9475 and the lower boundary is 4.6170. Therefore, the range for the later 100 is 8.97. Next, the KPL for the upper boundary is 24.221 and the lower boundary is 221.671. Therefore, the range for the KPL is 37.6. The cylinders for the upper boundary is 5.64 and the lower boundary is 5.030. The range for the cylinders is 5. Next, the horsepower for the upper boundary is 1.0829 and the lower boundary is 1.0065. So, the range for the horsepower is 1.84. Lastly, the weight for the upper boundary is 3.06. 193 and the lower boundary is 2.89324. So the range for the weight is 3.527.
Moving on to the next section, which is the prediction modeling using the software analysis of SPSS, and it shows the Pearson product moment correlation for each and every sector that is stated and shown in the table of a sector liter per 100, cylinders, kpl, horsepower and weight. As we can see that there is a strong correlation between each sector of liter per 100, kpl, cylinders, horsepower and weight, where it displays through the power analysis table of Pearson correlation with the formula of y equals to BO plus B1x1 plus B2x2, where y is 612, x is 725, B1 is 713 and BO is 949.
In conclusion, we have collected all of the data statistic of vehicle brands by liter per 100, kpl, cylinder, horsepower and weight. There are 3 measures of central tendency which are commonly used for group data. There is mean, median and also in addition, we also use measure of variation to quantify the amount of variation in a set of random variables which are range, variance and standard deviation. Apart from that, we are using SPSS to analyze and compare with manual measure of central tendency, measure of variation and measure position, and also show the result with hypothesis testing, correlation analysis, confidence interval and also prediction interval. That's all from me. Thank you.